All right, welcome back. Missed you all so much. All right, so it's time for our favorite question. So we're continuing on using particle motion from a calculator. Now remember, if the AP says you can use a calculator, use it. I promise you the numbers are very ugly when they say you can use a calculator. Now it's not saying you don't need a calculator. Most of you guys can probably solve these by hand. However, the calculator will make it much nicer for us. So we've talked about when the particle is at rest. Of course, that's our first derivative test. We found total distance and displacement. We found the acceleration at time t. And remember, when we found that acceleration, we don't ever use it. We're going to always use our calculator. They say you can use a calculator, use it. Even when we're looking for speeding up and slowing down. Now, hopefully you remember, for these, we are going to need the critical numbers for both velocity and acceleration. So we already have the ones for velocity, so let's go and take a look at that. My critical numbers for velocity are, that's where velocity was 0, we have the one value, t is 1. Well, let's do acceleration equals 0. Well, where does acceleration equal 0? Man, I do not want to solve that equation. Let's take a look. So, how can we find that then on our calculator? So to find out where the acceleration is 0, remember, this is my velocity curve. And we should remember that acceleration is the slope of velocity. In other words, it's going to be, we are looking for the turnaround. We talked about that yesterday when we looked at the graphs. It's an amazing video. Go look at it. We're looking for the turnarounds or the maximums or minimums. See, where the function turns around, it becomes a minimum here. So I'm looking for this point right here. And I can find that on my calculator. So it's going to be menu. So I press menu, go down to analyze. And I'm looking, in this case, it's going to be a minimum. It's going to be a minimum. And minimum or maximum, depending. And I can find it. It says lower bound, so I go to the left of it, where I think it's going to be, right here. Now, you might have more than one. This game we only have one here. Minimum. I keep scrolling, and it's going to give me, I don't have to hit enter for the output maximum. And what I'm looking for is two things. I'm really looking at that value, that t value. And we get 1.73. So we're going to get t equals 1.73. It's actually 1.732, but my calculator's not going out that far right now for some reason. We'll fix that later. So I am now looking for my second, double sine test. So we might remember that. So we do our double sine test, starting at 0. On top I deal with my velocity. My only critical number is 1. And remember, when we did our velocity, it was positive and then negative. So positive, negative, and then I go over here to 1.73. Remember, it should be a 2 there. And if I look here, I am now for the acceleration. Remember, for velocity, it was those values. But for acceleration, it's the slope of velocity. So between 0 and 1.73, the slope is negative. So the acceleration is negative. Afterwards, it's very slightly positive. Not much, but it's positive. So it's a positive acceleration. And we talked about the other day, if we want to find out when something is speeding up, we are looking for where the signs are the same. So take a look here. Let's think about this. Remember, between 0 and 1, this is saying we're going forward, but because my acceleration is negative, we're going forward, but we're slowing down. You might be approaching a stop sign or something. Between 1 and 1.732, now our velocity is negative, but our acceleration is also negative. So we passed up that stop sign, and we have to back it up to get onto before we hit the crosswalk. Okay? So that's what we have here. So to speed up, we're looking for those same signs, and they occur between 1 and 1.732. And that is because velocity and acceleration are the same signs. I know, we kind of ran out of room there. So when are we slowing down? When we're not the same. 0 to 1 or 1.732, there's no restriction on there, to infinity, and that is because, oh no, v of t, the velocity, and acceleration are opposite signs. Oh man, I way ran out of room on that one. Okay, so anyway, so that's how we answer speeding up and slowing down. Very easy to do. All right, let's see here. So let's continue on. Different type of question. A particle is moving along the x-axis. T is greater than 0. Finally, they gave us the restriction, right? We don't have to think about that. Its velocity is given by this. V of t equals nu. You can always tell you have a calculator question. Look how ugly that is. I mean, that doesn't look nice. You're not going to solve that by hand. So, definitely a calculator. You can always tell if you have a calculator question. What is the acceleration of the particle at t equals 4? So, we know we're looking for the acceleration. What is the acceleration of the particle at t equals 4? Well, we know how to get acceleration. Now, one, you could take the derivative of this, because that's what we need to do. Remember, acceleration is v prime of t, right? So I could take the derivative of this, but we don't have to. This is a calculator question. See, this is what they're really trying to test you on. Okay? They're not trying to test you if you know what the derivative of cosine is. They're asking you, do you understand the derivative here? Do you understand what the derivative finds? This is what they are asking you here. Do you understand what the derivative finds, particularly in a question like this? So you don't have to take the derivative to show you that you understand it, because a lot of people, if you take that derivative wrong, you can get the answer wrong. And this is only like a one or 2 point question. So the best way to answer this is to use your calculator. Remember, if the AP says you can use a calculator, use the calculator. So what I'm going to do, they gave me velocity. So if I want to find the acceleration at 4, I want v prime of 4. I am going to graph velocity on my calculator. Not the derivative, just the velocity, to find this. So, where's my calculator at? I'm going to clear out my memory. Doc B, that's why I have to clear it out. Go back here, and I'm just going to type in my equation. Remember, make sure you're in radian mode, no degree mode here. Once had a student forget to put radian mode. Thought they aced the test. They came back. They were very sad when they realized that they had it in the wrong mode. Be careful. We get cosine, 4.1, cosine of 0.9. Whoops, I should be in the graph mode. Sorry about that. There we go. 3 plus, there we want to graph it, 4.1 cosine 0.9x. We got to use x, not t here. When we press enter, it's going to look pretty ugly there. Oh look, it's a cosine curve. Look, there it is, the world famous worn out function right there. Alright, so we're looking for v prime. Remember, this is the slope. This is our rule. Go to menu to get the slope. Go to menu from a graph, right? From the graph. We go menu, analyze, Dwedx, dy dx. Press enter, and all I have to do is type in where I want to find it. 4. Press enter. There it is, 1.63. So we get 1.63. It's actually another 3 there, but my calculator is not showing that yet. You should go out 3 decimal places. There should be another 3 there. So I might have to fix my decimals here. All right. Last question. Another question right here. This is a great one. Ready? A particle moves on a straight line. Its velocity is given by this. Again, how can I tell that this is a calculator question? Yeah. Do I really? This is what I ask myself. Do I really want to take this derivative? And if the answer is no, it's a calculator question. See, it's easy. Is the speed of the particle increasing or decreasing at t equals 4? Give a reason for your answer. Ooh, they're talking about speed. Increasing or decreasing. So they're really asking us, are we speeding up or slowing down? And so we've talked about this before. If we're speeding up or slowing down, we're going to need velocity and acceleration. And since they gave us the velocity graph, that's all we need. We just like the velocity graph. So I'm going to graph my velocity curve here. I'm going to graph it. Again, I'm going to clear this out. There's a couple ways I can do that. One, I can just go up here and just, whoops, escape. Just like we want to do with school, right? And I just delete everything. Delete, delete, delete. And I type in our equation. Negative 2 plus, and this becomes in parentheses, x squared, remember we've got to use x squared plus 3x, when we caret to the 6 over 5 minus x cubed. I mean, if anything says, don't touch me, this is definitely it, okay? So I type that in. I don't really care what it looks like, I'm just going to use it, okay? There's our graph right there. There's our graph. All right. So there's our graph right there. And now what we're going to do is we're going to find the velocity and the acceleration at these points that we need. Let's get rid of the label. Oops. It just gets in my way. Nope, don't want that. Escape. There we go. Delete that out of the way. All right. So I'm going to find the velocity. So I need both of those. So I find the velocity at 4. That's easy. This is my value, right? I just want to find the value because this is my velocity graph. So I'm just going to look at the value of this. Menu, trace, graph trace. Remember, so this is our graph trace feature on our calculator. Type in 4, press enter, and it gives me negative 11.5. Next, I need my acceleration at 4, which is my derivative at 4. This is our analyzed graph, and you're looking at that dy dx feature. So menu, analyze, dy dx, press 4, press enter, and I get negative, be careful, the negative 22.3. Now notice, my velocity is less than 0. My acceleration is less than 0. So what is this telling us? Well, at this picture right here, ready? It's concave down, right? And because my velocity is less than 0, and my acceleration is less than 0, we are speeding up. So we would say at t equals 4, the particle is speeding up. And that is because the velocity at 4 and the acceleration at 4 are the same signs. Should be accelerate. And that's all we need to put for our answer right here. Now, you could do this without a calculator. Absolutely you can. But it's going to take you a lot longer. Now, I went pretty slow through this, but honestly, most of you guys should be able to get this answer right here in less than a minute. All right, hope you guys enjoyed the video. I will see you all later. Bye-bye.